So first, let's come over here and we want to open TIA Portal and go through this nice long startup sequence. There we go. All right. And once we're in here, we can just come down to Project View on the bottom left and click into that. So we don't have a project open at this point in time. We want to Project Retrieve, and we're going to retrieve this project. So I've got this sitting on my desktop, and there it is right there. It's this Hydro Plant Project.zap15. Let's go ahead and open that, and it's going to ask us for a place where we want this to live. And for me, I'll just go ahead and put this right on my desktop. So I'll just select desktop up here and hit OK. And it exported that to a folder and opened it, and there we go. Now I'm inside of that project, just like that. Let's come over here and I can expand my PLC and device configuration. We can see what's already in here, and all I've got at this point is the PLC, just because I had to create that in order to create the logic. So let's move those properties down so that we can actually see the PLC. We don't have any I/O modules, nor do we want any I/O modules, because we're only going to be using registers. From there, I want you to set up your HMI. So I'll go ahead and do mine as well. That's PC Systems Somatic HMI Application, if I can get it to expand, and I want my WinCC RT Professional. Wait for it while it creates it in the background. Get that guy up in front of me. Come on, load, baby, load. There it is. And then we need to bring in our communication module. So that's Profinet, Ethernet, and come down here to IE General and drag that in and drop it right there. I'm going to go ahead and configure my network. So let's click Devices and Networks, Connections, and I'm just going to drag that line right across there. Done. And from there, let's go over here into our actual program blocks, and I want to show you what we've got. You see this SimLogic DB and SimLogic? That is the actual logic that I created, and it's not intentionally unreadable, but I certainly didn't work to make this readable. So this is just kind of alphabet soup and a lot of different function blocks. You don't need to get in here and really do anything. It's all done. If you're feeling ambitious and you want to try to reverse engineer my code and modify it or something, be my guest. But really, all you have to do with SimLogic and SimLogic DB is ignore it. Just leave it alone. Over here in main, I'm calling SimLogic right here in the first network on the only rung that's in there. It doesn't matter if you put logic before this or if you put logic after this, but this needs to remain somewhere in your program. It needs to be run. It needs to be on a rung at some location inside of your program. Okay? So at this point, you're really pretty much ready to take off, but there's one piece of logic that I want to show you and set up. So coming down here, I'm going to work in network 2, and I'm going to put a comment here, which 1 equals LAD, comma, 2 equals FBD, comma, 3 equals SCL, comma, 4 equals STL. So that will remind me while I'm programming what these different things actually mean and what they do while I'm setting them up. So the first thing I know is I'm going to want a button on my HMI that's going to select this thing. So let's put a tag on there, and that's going to be PB underscore LAD. PB meaning push button and LAD meaning ladders. And let's hit enter. And the next thing I'm going to want is I want a trigger, because I only want things happening one time when someone pushes a button. So let's put a p-trig on there, and I'll give it one of my famous ONS1 addresses. And then after that trigger, I know I want to do a move operation because I'm going to want to set an integer. So let's put a move there, and I'm going to set a 1, and I'll call that PROGLANG, programming language. All right, so let's right click, define tag. This is going to be global memory of type int. I can define that. Right click, define tag. This is going to be global memory bool. And this guy is going to be global memory, also bool. Okay, so I've got one rung there, and I need to copy all of this stuff. So select it all, Control C, and I need 1, 2, 3, 4 more of these rungs, because I need one rung that's going to handle any kind of exceptions, i.e. when my proglang int is not already set to something, like it's at 0, or if somehow it magically gets set to 5, I need something that's going to kick it back into this range of either 1, 2, 3, or 4. So I'm going to come down here, and these are going to be my different options, 2, 3, and 4. And I've got different buttons for each ones of these, and that top one is going to be my exception handling. So I'm just going to go ahead and delete that control, that condition out of there, because I know I'm going to put something else there. So let's start with that, and I'm going to come over here to Comparator Operations, and I'm going to pull in an out of range. So my minimum value is 1, my maximum value is 4, and I'm looking at program language. So I can paste that into there. And this is going to need a new one-shot, so I'm just going to call it ONS without a number on it. Define tag, that'll be a global bool. And if I don't already have a language set, I'm going to put a 1 in there. And that's going to be the same thing as here. If somebody pushes this button, I also want to set a 1. And actually, I can probably just combine these two rungs and be even easier about it. So let's do that. Let's just move this down here below, and then close it off. And then I can just delete all this junk. So, whoops, I think I've got too much junk selected. There we go. Right click, delete. Okay, so now if somebody pushes the push button for ladder, or if my program language is not within range, then I want to go ahead and set a 1. And I've got my trigger handling the push button, but this right here doesn't care anything about the trigger. Anytime my value is outside of that 1 to 4 range, trigger be damned, it's just going to go over here and move that 1. So now all I really need to do is set up my next 3 buttons. So I want a push button for FBD. And then what were my next options? I had SCL and STL. So let's create those push buttons, SCL there, and STL right here. Got it? And those need to be on different one-shots. Well, I've got my ONS 1, but I can go ahead and change that to that ONS, because remember I just created that ONS and ended up not using it, so might as well use it here. I'll use ONS 1 there, and then I'll just create a 2 and a 3 down here. Alright, perfect. Define tag global bool, and define tag global bool. Perfect. And I'm moving 1, 2, and 3, and 4 into my program language. I think I just need to define my buttons now. So once again, global bool, define tag, global bool, last one, and all set. Okay, so let me move my properties and just resize this a little bit. So now I've got that language in here. This network 2 is going to give me these functionality on these 4 push buttons, and it's going to allow me to set program lang to either 1, 2, 3, or 4 to determine what program runs. And the last thing I need in this main is I'm going to come down here and we're going to look for some more comparator functions. So I'm going to pull an equals down here, and this is where we're going to decide which function blocks get called. So we're going to look at program lang. I'm just going to paste that in there and see if it's equal to 1. And if it is, then I'm going to have my calls to different function blocks over here. The first things I'm going to program are going to be my I/O. So I'm going to come over here and let's add a new block. And this is going to be my I/O underscore LAD. So I/O programmed by ladder diagrams. Let's select the ladder logic paradigm and hit OK. And there we go. I'm just going to close it immediately, drag this over here and drop it. And we'll let it create a database. So now we're going to call this function, we're going to call this program block anytime our program language is equal to 1. And let's copy this rung, and I'm going to have 3 more networks because these are going to get to be pretty big once we really start adding a bunch of code into these and creating a bunch of different program blocks. So I'm going to give each one of these its own network for organization's sake. And we're going to be looking for it to be program lang equal to 3, 2, 4, or 1. Whoops, that should be a 2. So 1, 2, 3, and 4. And then we're going to be calling different blocks. We're not going to be calling those same ladders. So we can delete those ladders out of 2, 3, and 4. Shouldn't have pasted them in there in the first place. And I'm going to create myself 3 more program blocks. So I want an I/O underscore FBD. That's going to be function block diagrams. Let's hit OK on that. And close it as soon as it opens. And let's go ahead and drag that over here right next to where we're checking for number 2. And let's let it go ahead and create its database. Create another function block. And this one's going to be I/O underscore SCL. Obviously that's going to be programmed in SCL. Hit OK. As soon as it opens, let's go ahead and close it. And then let's drag that right over here where we're evaluating on 3. Allow it to create a database. 1 more program block for now. We're still going to end up creating a whole bunch more throughout this project. This is going to be our STL. Change the language to STL. Make sure it's a function block. Hit OK. Close it as soon as it opens. And drag that down here where we're evaluating program language against the number 4. Okay. Now, what we're going to do is anytime we add another program block, like let's say we're going to add alarms, well, I'm going to come in here and I'm going to do all the same blocks for alarms. So I'll have alarms underscore LAD. And once I create that guy, got it, close it, and right over here where I already called my I/O, I'm just going to drag this over here, and I'm going to give myself 1 more call, and I'm also going to call alarms. And for every new ladder program block I create, I'm just going to drag one more branch down here, and I'm also going to call that program block. And I'm going to do the same thing with my function blocks and with my SCLs and with my STLs. So that is all I really want to have in main. And for right now, we can just leave it there and we can wrap on that.